Hey guys, so today we are going to discuss the Cohen Sutherland line clipping algorithm. So in this we understand that by Cohen Sutherland algorithm we will be doing line clipping. That is, suppose we have a polygon, say we have a rectangle in which there are certain lines passing through it. Now we will only be interested in the lines which are passing through the polygon and which are confined in it. Suppose we have another line which is outside it. Let us say this line. So the lines that we are only interested in, or the parts of the line which we are only interested in, are this part and this portion and this portion. We are not interested in this line as it lies completely outside the polygon, and also in these segments as the remaining part of these line segments lies outside. So what we are only interested in these portions. So now we will use this algorithm in order to find out that how we will be finding out what lines point we have to take in and what points we have to remove. So let us first draw the diagram in order to understand that how we have to use Cohen Sutherland algorithm. Suppose we have a line over here. Suppose we have 9 segments and this is the main box that we need. So now we have a formula in Cohen Sutherland algorithm that is known as T, B, R and L. Not a formula, but it's a technique that it's the top. This T denotes the top, this denotes the bottom, R denotes right, and L denotes left. That is, this is the left part, this is the right part, sorry. This is the left, this is the top, and over here is the bottom. So now we are going to plot 4 pixels in each of these boxes. Now how the pixels are to be plotted, let us see. Let me change the color. So first of all, take T, B, R and L. Now let us consider this quadrant, that is over this portion. Now does this point lie below the line, that is below the this polygon? Yes, it lies below the polygon, so it does not lie on the top. So we will write 0 over here. And this point lies below the polygon, or we can say that this lies at the bottom. So we will give this B as pixel 1. Now over here, this lies on the right as well because it lies on the right hand side of the polygon. So we will write 1 over here again. So if it lies on the right, then it cannot lie on the left. So we will put 0 over here. So the coordinates for this portion will be 0, 1, 1, 0. Now similarly, we have to find each one of them using TBRL. And the midpoint and the main polygon will be given the coordinates 0, 0 and 0. This is the reference coordinate. That is, it will always be 0, 0 and 0 for the polygon that we are considering. That is over here. Now let us start from here. Let us see T, B, R and L. Now this point lies on the top, so we will put 1 over here. This does not lie on the bottom obviously because it lies on the top, so 0. And this does not lie on the right, this lies on the left. So we will give 1 over here. Similarly, let us see for here, that is T, B, R and L. Now this does not lie on the top, this does not lie at the bottom, and this does not lie on the right, this only lies at the left portion. So we will be writing 0, 0, 1 over here. Now similarly, we will be using TBRL formula over here. That is, this does not lie on the top, this lies at the bottom, and does not lie on the right, it lies on the left hand side. So we will write 0, 1, 0, 1. Now over here we will again use TBRL, and on doing so you will get 0, 1, 0, 0 because it only lies at the bottom, not at the right, not at the left, and neither at the top. And similarly we will use TBRL over here, and over here. On doing so you will get the values as 1, 0, 0 over here and 1, 0, 1, 0, and lastly in this segment we will get 0, 1, 1, 0, 0, 0, 1, 0. So these are the important pixels or the important pixel series that you have to remember. That is, in each quadrant we have a different pixel. So these are the things that you have to remember. So now let us plot the coordinates of this polygon, that what they will be denoted as. So this portion will have 2 coordinates, that is the x coordinate and the y coordinate. The x coordinate will be called as the x minimum and the y coordinate will be given as y minimum. And over here we will also have two coordinates of x and y, that is, this will be called as x max and this will be called as x minimum. So these are the two coordinates of the polygon. So now let me draw this polygon again and let me write the coordinates again, that is, this is x max, this is y max, this is x min, and this is y min, this point and this point. So now for a point to lie on the top, that is, suppose for a point to lie on the top, the y axis of that point should be greater than y max. That is, let me draw the lines again. So these are the lines that we have for the polygon. So now let us see that what we mean by this, that if the y coordinate is of a point is greater than y max, then this will lie on the top. Suppose if a coordinate has y which has greater than y max, then it will lie somewhere in this region. So this region is always given at the top. So this means that the coordinate that we are given will lie at the top. Similarly, for a point to lie at the bottom, the y coordinate should be less than y minimum. That is this coordinate. Now if the y coordinate is less than y minimum, then it will lie over here. That is at the bottom. Now similarly, suppose if for a point to lie on the right hand side, the x value of the coordinate should be greater than x max. That is, this is our x max, and if we have an x coordinate which is greater than x max, so this will lie over here, that is on the right hand side. And lastly, for a point to lie on the left hand side, the x value of the given coordinate should be less than the x minimum of the polygon. That is, this is the x minimum value, and if we have a coordinate say x and it is less than x minimum, then it will lie over here, that is on the left hand side. So these are the things that you have to remember while plotting a point. Now let us see an example in which we will be able to understand that what are the different criteria or the different lines that we can see in different types of questions. So first of all, let us draw the diagram. That is, these are the lines that we have. And this is our main polygon, which has the coordinates as 0, 0, 0 and 0. That is the reference coordinates. And as we discussed earlier, that is how we have to find out the coordinates for the pixels for the different quadrants. So we will write them over here directly. That is, we use T, B, R and L in each of the quadrants. So using that, we have written 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 0 and 1, 0, 1, 0, 1, 0, 0, 0. So these are the pixels that will be plotted in each of the quadrant. So now let us consider different lines that we can face while solving a question. Now suppose we have a line, say over here, then we have another line over here, then let us say this line intersects the polygon and it lies in the top quadrant, and similarly we have another line which intersects the polygon and lies at the two quadrants, that is 0, 0, 1, 0 and 0, 1, 0. So these are the four lines that we can face while solving a question. So now let us name these lines. So let us say this is line P1, this is point P1, this is point P2, and this is point P3, this is point P4, this is P5, this is P6, and this point is P7, and this is P8. So now let us see what different scenarios we can face. So let us take case 1. That is for the line P1 and P2. Now let us write what are the pixel coordinates or the pixel points for P1 and P2. So for P1, we have the pixels as 0, 0, 1, and for P2 we have the pixels as 0, 0, 0, 1 because they lie in the same quadrant. Now we will take their AND, that is the AND operation. Now you must remember AND operation, that whenever we have 0, 0 and we do their AND, then we will get 0. And similarly, if we have 0, 0, 1 and we have 0, 0, 1, 0, 1, then the points that we will be getting will be like this. That is, we have applied the AND operation. That is, these are the binary points, that is 0, 0 will give us 0 when we do the AND operation. 0 and 1, sorry, this is 1. 0 and 1 will give us also 0. 1, 0 will also give us 0. But only 1, 1 will give us 1. So this is what the operation we have to do on these 2 points. That is P1 and P2. So on doing so the AND operation, you will get 0, 0, 0 and 1. So now you will see that we have 1 in our resultant. So let us come to property 1, that whenever there is 1 in the resultant of AND operation of 2 points, then we can say that the line that we are dealing with lies outside, or we can say completely outside the polygon. That is, as we can see from the figure, it is self-explanatory that this point lies outside the polygon. So this will be straight away rejected, as we are only considering the lines which will either cross the polygon, or which will totally lie inside the polygon. So this is our case 1. Now let us come to case 2. Now in case 2, let us consider the points P3 and P4. So these are the 2 points P3 and P4, sorry. That is, P3 is over here and P4 is over here. Now we can see that the pixels or the codes of P3 and P4 are 0, 0, 0, 0, 0, 0 and 0, 0. That is, they itself lie in the polygon. That is, for P3 we have 0, 0 and 0. For P4 we have 0, 0, 0 and 0. So now if we do their AND, that is, we apply AND operation on these 2 codes, then we will get 0, 0, 0 and 0. So now let us come to our property 2. Now whenever we have all zeros, that is, all zeros, not only in the resultant but in the points as well, that is, the points as well as the result all have 0 values, then it will mean that P3 and P4 line segment, or we can say a line, will always lie inside the polygon. That is, it will lie completely inside the polygon. That is, we have the polygon, a line will be lying over here. As you can see from the image that we have, in the diagram that we have, that P3 and P4 lie inside the polygon. So we need not do anything. We will simply accept this line as it is inside the polygon, and no clipping is required. There is no clipping required because the line already lies inside the polygon. That is what we want. And it does not lie outside. That is, we won't reject it. We will accept it as it lies inside the polygon. So now let us come to case number 3. That is our case 3, in which we will consider the points P5 and P6. So now let us see from the diagram that what is P5 and P6. Now P5 lies in this quadrant, that is 1, 0, 0 and 0, that is 1, 0, 0, and P6 lies inside the polygon itself, that is 0, 0, 0, 0. So we will write the codes for P5 and P6 points, that is 1, 0, 0 and 0, 0, 0 and 0. Now we will apply the AND operation on these 2 points. On doing so, you will get 0, 0 and 0. Now this point, this line segment can be accepted and the rest is to be clipped. That is, from this we can see That is, this is now our property 3. That is, we can see that the point lies partially inside the polygon and the other part lies outside the polygon. So what we will be doing is here that is, suppose this is a polygon and a line lies like this. So what we will do, we will be clipping this part and only accepting this part. So clipping is required and the part inside the polygon is accepted. So this is what we will be doing over here. That is, this portion will be clipped, that is, this will be removed, and only this portion will be accepted. Now let us come to the last case. That is our case number 4, in which we will be considering the points P7 and P8. So now let us see what are the codes for P7 and P8. Now we can see that P7 lies in this quadrant, that is, which has codes 0010, and P8 has code as 0100. So first of all, let us write the codes for P7, which is given as 0010, and for P8 we have 0100. Not doing so, you will get 0, 0 and 0. So now these points may or may not need clipping. That is, the line segment formed by these 2 points may or may not need clipping. But in this case, we can see that our point P8 lies over here, P7 lies over here. So the points that we have to consider, or the line segment that we have to consider, is only this portion. And this part have to be clipped. That is, these 2 portions will be clipped and this portion will be accepted. So this is what we have to do over here. We discussed our 4 cases in which we considered every case. That is, when the point lies outside the polygon completely, and when it lies inside the polygon completely, and when it partially lies inside, that is, one point is inside and one point is outside, and when it crosses the whole polygon twice, that is, intersects at these 2 points. That is, both the points lie outside but they cross the polygon. So these are the four cases that we have to consider while when a numerical is given to us. So now let me explain that how you will solve a numerical. Now let us take any polygon. Let us say this is the polygon, and we have been given coordinates as -8, 8, and this is -8, -4. This is +12, -4, and this is +12, 8. So these are the coordinates which are given to us. Remember that this is x-min, this is y-min, this is x-max, and this is y-max. So now let us draw our boundary lines. That is, these are the lines. Now suppose that we are given a point, say 17, 11, and we are given another point that is -13, 5. Now as we can see that -13, 5, that is the x-axis, will lie on the left hand side. So this portion will lie on this side. So now whether it will lie in this quadrant, or this quadrant, this will be decided by the y-axis. So over here we have 8 and 5 is less than 8, but 5 is greater than -4. So our point will lie over here. That is, -13, 5 will lie in this point. That is in this quadrant. Now let us come to the point 17, 11. Now we can see that 17 is greater than 12. That is, this is 12 and this is also 12. So it will lie somewhere over here. So now in order to find in which quadrant it will lie, let us see that whether it is greater than 8, less than 8, or greater than 4 or greater than minus 4, less than minus 4. As we can see that 11 is greater than both, that is 8 and minus 4 as well. So it will lie somewhere over here. That is, this will be our point 17, comma 11. So now let us join these two lines. Sorry, it came out to be a little crooked. I'll not draw it again. Suppose this is the point that we have to find. This is the line segment that we are given. So now we have to find only this portion, and the rest of the portion will be clipped. That is, we have to find this point A and this is the point B. Now what we will do is, first of all, we will find the equation of the line. Find line equation. You must know that how we have to find out the equation of a line, that 2 points are given, that is x1, y1 and x2, y2. Now using that we have to find out the coordinates of the line. So now on doing so, you will get the coordinates, or you will get the equation of the line. Now you will simply use that equation of the line and we will come to point A. Now in point A we can see that the y-axis is equal to 8. Now suppose that we found out the equation to be as y minus 5 is equal to yx plus 13 by 5. This is the equation which came out from these 2 points, that is this point and this point. So now what we will do, in order to find point A, we will put the value of y as 8 because y is constant in this area. That is, we will simply take y and put it as 8. On doing so, you will get the value of x as 2. That is, the coordinates of A will be 2, 8. Now similarly, what you will do for B is, instead of taking instead of taking y, we will take x. That is, we will consider x to be minus 8 for this line segment or for this point B. As we can see that minus 8 is common over here. Now for B, this was for A. Now for B, we will put the value of x as minus 8 in the equation of the line that we had already got. On doing so, you will get the value of y as 6. So our new coordinates will be minus 8, 6 of point B, and this was A. That is, this coordinate, just a minute, let me change the color. This coordinate will be given as minus 8, 6. So this line segment, that is the line segment between point A and B, that is between the point 2, 8 and minus 8, 6 will be the line segment that we need, and the other line segments will be clipped off. So this is how you have to find out the lines which will be clipped and which will be accepted. So this is a very easy algorithm. You just have to simply apply a little mathematics. That is, you first have to find the equation of the line, then consider the two intersecting points, that is A and B. Then in one of them put the coordinate in which y is constant, and in the other put x in which it is constant. Now doing so, you will get the two coordinates of A and B, and simply the line between these two coordinates has to be accepted and the rest has to be clipped. So guys, this is all for this video, and if you were able to understand that how we have to find out the Cohen Sutherland line clipping algorithm, just write wow in the comment section. It would be great to know that you were able to understand it. And please, before leaving the video, do not forget to subscribe our channel, and it helps us to create more such videos and help you to understand better. So now guys, this is it for this video. See you in the next one.